The goal of this video is to prove the theorem that we have in class that vertical angles are congruent. Okay, so nowhere in our proof are we going to use this statement. All right. The fact that our given says angle 1 and angle 2 are vertical angles, the definition of vertical angles essentially just tells me how do I find them. Angle 1 and angle 2, they're across from each other. Really nothing I can get from my given in this question. So we start to look at my picture, and the way we're going to prove that vertical angles are congruent is to look at angle 1 compared to angle 3. If I look at angle 1 and angle 3 together, they form that straight line. They form that straight angle. So, from what we've learned in class, we should know that measure of angle 1 plus the measure of angle 3 is equal to 180. Okay? And that's because these two angles together form a straight line, or a straight angle, and that's part of your angle addition postulate. Okay? And now about 90% of the time, when I make a statement like this, about two angles adding up to 180, I want to make another statement about two different angles adding up to 180. So if I look at my picture, we should recognize that angle 3 and angle 2 form that straight angle. So we'll say that measure of angle 2 plus measure of angle 3 is equal to 180. And that's going to be the same reason it's the angle addition function. All right? Now we've talked in class about how this is a pattern. We've seen other proofs at this point where whenever I have two, or a sum of two things or three things equal to 180, and another sum of two or three things equal to 180, I get rid of the 180s and I set those sums equal to one another. So I set measure of angle 1 plus measure of angle 3 equal to measure of angle 2 plus the measure of angle 3. That's either the substitution or the transitive property. Okay, transitive property would say if that's a generic statement A and that one's a generic statement B, that's got to be B as well, and that would be C. The transitive property says if A is equal to B and B is also equal to C, then you can say A is equal to C. So that's how we get these first two parts equal to one another. Okay. From there, the pattern continues, and we always want to try to, if I've got a sum on one hand side or left hand side and a sum on the right hand side, see if there's something value-wise or even symbol-wise that could be removed from both sides. Here, I recognize the measure of angle 3 is on both sides. I'll go ahead and write this underneath. But you recognize that they are those two parts are identical. They're on both sides. So I'm going to state that it's on both sides. Measure angle 3 is on the left. Measure angle 3 is on the right. When I say something like this, that's the reflexive property. Whenever something is equal to itself or something's congruent to itself, it's your reflexive property. From there, you actually want to remove those things. When I remove those items from both sides, and we get measure of angle 1 is equal to measure of angle 2. And the process of actually removing something from both sides is your subtraction property of equality. Okay? And actually all these properties are properties of equality. Transitive property of equality, reflexive property of equality, subtraction property of equality. Okay? And now that I know that the measurements are equal, I can make the conclusion that angle 1 is congruent to angle 2 through the definition of congruency. Allows me to go from knowing that the angle's measurements are the same, their degrees are the same, so then that's going to tell me that the shape and the size is the same. So that means that they're congruent. And now you've shown that angle 1 and angle 2 are congruent angles, and they are vertical angles. So we've proven the theorem then that vertical angles are congruent.